My name is Richard Card. I am the industry specialist for Telco at SUSE, and I'm joined by my colleague Tim Ernish, who is our Telco product manager, and we're going to take you through some of the challenges that the telco industry faces today in terms of modernising their network and how we help tackle those challenges. So in order to understand the challenges, I'm going to have to take you back to a simple time, a time of social distancing, face masks, and wearing your best PJs to work. Of course, I'm talking about COVID. The COVID-19 pandemic taught us many things. It taught me that I am not a teacher, and the sooner my kids could return to school, the better off they and I would be. But it also had significant impacts as well on the telecommunications industries. It really highlighted our dependencies individually, but also the dependencies of our global economy, our emergency services, and it highlighted just how, I suppose, not ready the network was for that surge in demand, right? All of these people returning to home to work, more or less the world's population, classrooms moving online, people spending extra amounts of time at home, and what was there to do? Well, stream, online game. It increased a massive demand on the network, which the telcos still struggle to keep up with today. And despite the fact that over the last 6 years, globally, the telco industry has invested not far short of $1 trillion on upgrading that network, one of the things that they really struggle to do is monetize. Now, if we look at some of the key challenges that the telcos face in today's rapidly evolving landscape, it can broadly be categorized into these areas. If we look at the technology challenges that they face, when we look at the advent of 5G, the rollout of that technology requires significant investment in both infrastructure and spectrum. But many telcos, and I see we have a few in the room, can attest to the fact that many of them are running on old legacy systems which are expensive to maintain and upgrade. It also lends itself to the competitive challenges. Most countries in the world are heavily saturated by the number of telco players, which often makes it difficult to remain competitive and generate margins. Add to this the increasing demands of focus, should I say, on sustainability, which means telcos need to invest in greener technologies, is also quite resource intensive and costly. Addressing these challenges requires telcos to continuously innovate and make wise investments to adapt to the changing landscape. So how are they going to do this? As we said, monetizing the network is key to much of the success here. Building out the next generation of networks requires significant capital investment, so they need to be able to realize a return there. The advancements in technology, and we've seen a lot of conversations this week around AI. So if we combine that with IoT, AR, VR, where telcos are maintaining networks to support the evolution of those technologies, they have to continuously fund the growth there as well. So how can they look to do this? And there are a number of ways that they are looking to do this, but two of the ways that we're going to talk about today is around 5G. Everybody's familiar with 5G, but that's the platform for the telcos to progress to the next tier, to realize the benefits of monetization, the 5G network. And it is quite important, the 5G transformation, because it highlights a number of benefits that they can capitalize on, that they largely missed out in the previous decade of revolution, when over-the-top services like streaming and messaging went to other companies like Netflix and WhatsApp, right? They were still using the infrastructure, but the telcos were not benefiting from the revenues. In terms of innovation, telcos also need to differentiate themselves and bring new services to market. Again, the 5G transformation and how they monetize that is what's going to help continuously provide new services to take to market. And then secondly, and one of the major strategies for us here at SUSE is around the edge. The edge cloud transformation for many telcos sits not just within the core of the network, but it also sits at the edge of the network within radio access, within the cell tower. And the reason that they're exploring this is to improve efficiencies in service provision, but also reduce costs. As we move edge processing closer to the consumer, i.e. the cell tower, it significantly reduces the latency and improves the real-time experience for all of its consumers. Again, by processing that data locally at the edge, it also optimizes the bandwidth, which lowers the costs for the consumer as well. And then also when we think about security and how edge keeping that sensitive data closer to the source, it also enhances the security and privacy that they need to adhere to. So when we look at edge as a strategy, it's quite clear that it enables telcos to deliver faster, to be more efficient, and to innovate services that they offer to their customers. So what we're going to do now is I'm going to hand over to Tim, and he's going to talk in a bit more detail around what that looks like. So, Tim?
Thank you.
You're welcome.
All right. So the point I want to get to eventually in the remainder of this talk is I want to basically illustrate how edge computing solves two problems for the telco industry or for telco operators. In order to unpack that, I need to go back to talking about how we got to the point of discussing edge computing in telecom networks. So let's first take a look at why did we do cloud in the first place, and then why did we actually expand the application of cloud technology into telecommunication networks? What were we trying to do? So just like all the way back, why was cloud invented in the first place? Where did it come from? What's the idea behind? At the end of the day, and this is of course something that can be a story that can be told in many, many different ways. The way I'm telling it is the cloud is about flexibility. It is about getting what you need when you need it and not paying for something you don't need or don't use. That is one fundamental premise on which the principle of cloud computing is built. So at the end of the day, it's about cost effectiveness. It's about making sure that you don't pay for or run infrastructure that you don't need, and that you can flexibly scale up when your demand goes up. Another promise of cloud that is often talked about is simplicity. If the operational responsibility for actual physical infrastructure gets shifted to someone else, life can become simpler. The reality of cloud as we know it today, you think of the how many 250 different services in AWS, it's not actually simpler. The simplicity comes from the ability to automate. With cloud, we have gotten significant technological advances in infrastructure automation. The whole idea around infrastructure as code, as in you basically specify your desired state for infrastructure and then you sort of throw that into some form of a deployment tool, think Terraform, has created, let's say, a different distribution of complexity along the timeline. You have complexity up front, but in the actual day-to-day reality of operation, it can become simpler. So NFV, Network Function Virtualization, is effectively cloud for networks. Like networks were initially not necessarily part of the idea of cloud computing. Cloud computing is something that happened in the data center and for traditional IT. But obviously, after a while, not long after the principle of cloud really took off in the industry, it was observed that the same principle could be applied to networks as well, because some of the problems cloud solves exist in networks as well. And there was the idea that some of the benefits could be beneficial there as well. The benefits were, though, a little bit different. The perspective of telecom operators on cloud is a little different compared to generic cloud. One very important desired benefit from cloud computing, which sort of as a side effect delivers, let's say, a more disaggregated vendor landscape and a different split of responsibilities across the ecosystem was that the telecoms industry really was looking for vendor disaggregation and for the possibility to run off-the-shelf hardware as opposed to highly specialized, vertically integrated appliances. The dominant argument why that is a good thing, if you look at the initial articles about NFV dating back to the year 2011, 2012, was that eventually there would be cost savings. The other important aspect for network function virtualization was flexibility. One thing that you get with cloud when you sort of disaggregate vertically integrated appliances is the ability to change only what needs to be changed at a given point in time and keep the rest of the system as it is. So, for example, when you want to replace your routing stack with a newer version, you don't have to buy new hardware unless the new version requires significantly more capacity in the hardware. Minor changes, like moving from one version to another, oftentimes don't do that, so you can reuse the old hardware. Previously, in the good old world of vertically integrated appliances, if you are lucky, you were getting a new software version for your Cisco router from Cisco, but from time to time, Cisco will tell you, no, we are not maintaining that device anymore. You will not get any firmware updates, or at least no significant functionality drops anymore. You need to buy a new box. So the separation of software from hardware allows network operators to change only what needs to change at a given point in time, or at least it facilitates it. Like, the world is not perfect. There are exceptions from this, but by and large, it gives us flexibility in this dimension, and with that, it gives us service velocity, which means that the network can evolve faster. So that was basically, if you study the articles that were written 2010, 2011, 2012, that is what the authors were claiming NFV would bring. So, where are we 10 years later? If you just look at it from an adoption point of view, absolutely yes. NFV has become the dominant deployment paradigm for core networks. If you look at the websites of Ericsson, Nokia, etc., packet core today, like mobile packet core, is only delivered as a cloud appliance. You cannot buy vertically integrated cloud packet core anymore. It's not on the market. Of course, it still exists, right? The old boxes are still running, and they are also maintained according to the SLAs and the contracts customers have made over time. But if you look at the offering as of today, if you deploy greenfield, it's not there anymore. It has completely been displaced by NFV. And also in the fixed network, the adoption of virtual routers and SD-WAN in general, like software-defined wide area networks, transport network, is growing steadily. The portfolio shift hasn't fully completed there. You still find both on the market, but also if you just look at greenfield deployments, the number of times virtualized appliances are being deployed is far higher than when like new vertically integrated appliances get provisioned. What about the cost effectiveness stuff? That is actually a pretty difficult question if you start to unpack it. I think it's fair to say, by and large, that instead of actually bringing the overall capex for the network down, it has mostly shifted the cost structure. General purpose server manufacturers like Dell and HPE and Lenovo get a bigger share of the overall wallet of the customer because it's their machines that are being used in the networks. The classical network equipment manufacturers like Ericsson, Nokia, Cisco, etc., are basically either purchasing their machines from Dell and HP and are passing them on to their customers, or they basically just specify what hardware the end customer is supposed to buy, and then a part of the budget goes to Dell and a part of the budget goes to Ericsson, for example. That, of course, shook up the ecosystem, right? Like the traditional and established ways of doing business, the customer relationships, who owns the customer, all that has been shaken up. And what happens when an ecosystem gets shaken up? It accelerates innovation. So I think it's fair to say that NFV has accelerated innovation. And that is not a small thing, right? Because the telco industry wasn't particularly known for the fastest possible innovation. If you look back at the let's say, at the 80s and the 90s, like in the era of networks being privatized, getting out of state ownership, etc., the traditional telecoms industry wasn't the most fast-evolving industry. The benefit is maybe in a slightly different place compared to where it was originally expected, but it is nevertheless beneficial, and that is also the explanation why it actually has become the dominant paradigm. But to some extent, it also has become a self-fulfilling prophecy, because as I said, today you only get cloud appliances. So there is no actual competition between NFV and non-NFV anymore in certain areas of the network. It has just been it has just become the prevailing paradigm. So is this really the better way of doing it? The direct comparison is a little bit difficult, because it's a bit of a it's hard to compare. In my personal opinion, the real benefit of NFV is what I already alluded to on the previous slide. It is flexibility, it is control, it is the ability to run more incremental change in the network, and that leads to higher service velocity, so the network can evolve faster. And I think that is pretty undisputed in the industry. It has brought about complexity. Life has, in certain areas, become more stressful for the operations teams. But from an overall business benefit point of view, I think we can say the higher velocity and the ability to change the network more easily overall outweighs the disadvantages. What we've also learned along the way is that cloud is not necessarily only a technology, it's also a mindset. Because the overwhelming story that I get told by my customers is that we did it wrong in the beginning because we didn't really fully understand the cloud-native paradigm, and our vendors didn't understand it all the way either. They had the way cloud stacks and software interacted were not really optimized for cloud. The industry has learned a lot over the last 10 years, and it has become a lot better. Of course, there are still gaps, and this is not the end of the journey. But my observation is that the entire industry has become more cloud-centric, has become more used to thinking in terms of application of cloud technology, and that is actually the real benefit. Because as soon as people in the networking industry start to think like people in the IT industry when it comes to the way they operate, that is where the real benefits of cloud start to occur. In the middle of all this, of course, adoption continues further, and that is where I'm getting towards discussing about the network edge. Because if you watch closely, what we've discussed before is mostly, let's say, the center of the network. If in case of mobile networks, it's the core. In the case of fixed networks, it's mostly transport and aggregation networks. What about the network edge? What about the last mile? That is where NFV originally didn't happen. If you look at the big NFV projects that happened, let's say, before 2016, they were all in the center of the network. There was not a lot of virtualization going on the network edge. And that is changing now. And this is where things get really interesting, because this is where cloud computing, or as we call it in this case, edge computing, starts to deliver not only technological benefits, but also real tangible business benefits and additional opportunities for operators. So how did we get from NFV to edge computing in the telco industry? Let's simulate the dialogue that was going on in the industry. So the cloud guys, they basically went like, hey, I have basically cloudified my data centers, and I realized that there are benefits in doing that, flexibility, into automation, infrastructure as code, etc. But now I have a lot of stuff that's not in the data center, and I can't really move it into the data center. Like, for example, you can't really move the cashier system in a supermarket into the data center. You still need a device that you can actually scan your barcode with, and someone can swipe their card on. So you can't really get rid of local IT altogether, and there are lots of examples of that nature, right? The retail example is only one of them. So the basic idea of edge computing was, let's just use the same paradigm, let's use the same operational pattern, let's use the same tooling that we're using inside the data center and that we've gotten to appreciate over time also outside the data center, at the edge. That's, at the end of the day, what edge computing is about. Everything gets managed the same way, but it's data center or edge, doesn't matter. So that's when the network operators picked up on that, and basically went like, oh yeah, that sounds great. That solves one problem for us as well, because we couldn't really cloudify our entire network so far. Now with edge computing, and with the couple of technological advances that particular aspect has brought, we can actually cloudify the network edge as well. So that is where sort of the idea of telco edge or edge cloud for telcos came from. And at the end of the day, this would be the sort of the final victory for NFV, because that way the entire network could get cloudified, and we could realize the benefits for the entire network. The second part of that consideration was, hang on, if we do this and we get basically a little cloud everywhere, and all our customers, or basically everybody, is usually not more than 1 kilometer away from our nearest edge cloud, we could be the ones providing edge compute to the general public, because AWS is not everywhere. AWS has how many data centers in Europe? Maybe 5 big data centers and a couple of smaller ones, which basically means that the average distance to the nearest AWS data center can be in the ballpark of a couple hundred kilometers, as opposed to 500 meters. And latency-sensitive applications obviously benefit a lot from being a little bit closer to where the customers are. So this is where network operators started to see a significant additional business opportunity if they invest into really cloudifying their network all the way up to the very last mile. They gain the ability to provide compute services to customers in very nearby, very close to where the customer actually is. So what does that require? What does NFV and generic edge compute require? It requires even more automation, because while you in a data center still have a couple of technicians running around and doing things and plugging cables and so on the edge, there is nobody. It really has to work remotely. It really has to work reliably all the time. Every time you need to someone needs to get in the car and drive to the cell tower and do something, that's a very costly operation. We don't want that. At the same time, of course, and that is not necessarily a requirement that comes from edge computing, but it is something that sort of needs to be addressed at the same time. There was a technology shift from virtual machines to containers and Kubernetes, so edge computing usually is being conceived as container-based, Kubernetes-based, with VMs being the exception and containers being the norm. So that technology shift needs to be addressed at the same time. And last but not least, efficiency matters even more. In a data center, when you have a couple of hundreds or maybe even thousands of machines, there are pooling gains, and the way you map applications to physical hardware gives you certain efficiencies that you don't have at the edge. At the edge, you only have like as many machines as you need for a given use case. You may have predicted that to a certain extent, and when something unexpected happens and your usage pattern changes, you may become capacity limited more quickly. So efficiency matters a lot, and particularly the cloud stack itself needs to be super efficient, because if you have a small number of machines, you don't want half of them being eaten by your cloud stack and only the rest is available for workloads. So there are a couple of technological advances that need to be made when things go to the edge. But getting back to the idea of the edge, the cloudification of the network edge becoming an additional monetization path for operators. So once full automation at the edge is achieved, once the challenges I talked on the previous slide are solved, it is actually no longer that difficult to basically slice up your edge compute capacity into a part that the network itself consumes, and that can be provided to third-party applications. Technically, that's not really difficult to do. Kubernetes is inherently multi-tenant. You can just sort of dedicate a certain part of your capacity. If you need more nodes, you can add a few nodes to your cluster and reserve them for third-party workloads. However, what about security? Networks are critical infrastructure. They are very heavily regulated, and governments don't appreciate the idea of networks being easily hackable by whoever. So in order to really run networking workloads, like routers, optical line termination, or the RAN stack for radio base stations side by side with third-party workloads, you need to be damn sure that those third-party workloads won't do any harm to the actual network stuff. And that is not necessarily a technical problem, because technically there's, of course, a lot we can do, right? We can put hypervisors in between, we can use security policies, we can use zero trust security tools like SUSE New Vector to secure everything up to the point where we think it's secure enough. But as an operator, it's not my opinion that counts when things are secure enough, it's the government's opinion that counts. Because the government tells me what the security policies are that I'm supposed to apply to my network. I can't just decide this on my own. Like, every country has some sort of a security agency that basically makes the rules for operation of critical infrastructure. So, and that regulatory certainty for mixed third-party workload and edge cloud operation for networks is missing today. If you look at, for example, here in Germany, what the BSI says about this, they don't actually know. If you ask them, what is enough security in order to combine third-party workloads and networking workloads on my edge cloud, they have no answer. This is work in progress. So despite this being a good idea, we're not quite there yet, but not necessarily technically. I think technically this is absolutely feasible, but regulatory, we're not quite there yet. The next really interesting thing is, what about roaming? If I provide an edge compute service, as in I will make sure that the workload gets deployed close to you and people tend to move around, what happens if they leave the deployment footprint of my network? Like, what happens if someone travels from Germany to the UK and I have my contract with Deutsche Telekom? The mobile industry has solved this for over 20 years. It's called roaming. How do we do roaming for edge clouds? How do I make sure that a customer of Deutsche Telekom, when they go to the United Kingdom, can keep using local compute close to them, can take their workloads with them, and without having to have a commercial relationship with all those operators? There are a couple of initiatives going on in the industry already for quite some time, some of them that are trying to address that problem. It's ETSI Mobile Edge Cloud, the ISG in ETSI, and an initiative in the GSMA called Operator Platform. I have put links in the slides. If you check them later, you'll find them. So there's been a lot of conceptual thinking going on, and the practical implementation is right now studied in a European research project, which is called the CIS project, Cloud Infrastructure Services, which is an umbrella project with lots of research projects underneath. We are involved with some of our partners in those projects, and we're trying to sort of come up with solutions that eventually will hopefully get us there. So what comes next? Overall, for edge compute in telco, we need small footprint NFV stacks addressing both core and network edge requirements, and as I established, network edge requires a little bit more than core does. We need extreme levels of automation throughout the entire life cycle. The use of Kubernetes, I think, is a given. We are very heavily investing into cluster API and GitOps. We need industry alignment and standardized APIs and reference architectures. We are very invested into Project Silva, the AnuCat initiative, and also CNTT. This is where we believe the alignment across the industry is going to come from. We are actively engaging with regulatory authorities to drive legal certainty, because as we discussed, that is really one major roadblock that we as technicians or technologists can't really resolve. This is what basically the governments and the lawyers need to tell us. And last but not least, overall, we need to continue standardization and also research, for example, in the IPSI projects, to drive this whole idea of additional monetization paths to fruition. Thank you very much.